Hello, everyone, and welcome to today's webinar. I'm super excited today to be presenting the next webinar in our AI Agents in Action series. Today, we'll be going into the topic of agents for manufacturing and maintenance. So my name is Henry Equaro. I'm a senior solution consultant here at Dataiku, focusing on the manufacturing industry. And I'm joined today by my good colleague, Dr. Nicolas Mouet, who's a senior data scientist in our team. And essentially, our team works on tailoring the Dataiku platform to best meet the unique needs of manufacturing companies, such as yourselves. So to start off, I'd like to give a brief overview of what Dataiku actually is, what our platform offers, before we go into the topic of agents specifically. So essentially in our platform, looking at the overview here, going basically from the bottom to the top, we provide basically connectivity to all data types, all compute engines, wherever it may reside. So basically whatever data strategy you have, our platform is compatible. Also in terms of technology, tech stack, and the layer above that, basically companies can decide what the best tech is for them, what they need today, but also be ready for the tech of tomorrow by avoiding any vendor lock-in through our tech agnostic approach. And very important also the topic of governance. So we provide basically a framework to govern all the different steps you may have in the data to AI lifecycle, basically going from data prep all the way through to operations. Everything is fully governed with Dataiku, and this is also an increasingly important and critical topic now with the rise of agents. At the core of the platform, we offer basically any type of data-driven analysis you can imagine, so be it simple analytics, machine learning models, and also now recently building agents and coordinating them. And basically, in terms of the users, we really offer a collaborative solution that allows basically for all users to be met at the skill level they have. So be it no-code, low-code, or high-code users. And so while we're discussing agents today, everything that we'll be talking about is basically fully part of the Dataiku universal AI platform, as we like to call it. This means that our customers really benefit from a proven platform when they're thinking about the topic of agents, where they can cleanly connect agents to their data, their analytics, and their machine learning where needed. And it's really critical to note, in our opinion, that agents can't live in a vacuum. So if you really want a business value from them, and we really believe that they'll only be able to be truly valuable when they can integrate with all other objects shown in this diagram, and at the same time be governed and controlled in a similar manner. And the key value that Dataiku really brings is that our platform enables companies to do the creation of AI agents at scale while providing the right controls. So with that said, let's jump into today's topic of beginning with how AI agents could change the game for manufacturing. So maybe to begin, what are actually AI agents? It's really a topic where you ask three people, you'll get three different answers. But from our point of view, we basically see three components of what makes an AI agent. So first of all, at its core, it's an LLM-powered system. Secondly, it's designed to achieve objectives through multiple steps, while having the concept of going beyond just a simple single retrieval of one information. So that's how we define agents, and when we're presenting today, that's kind of the basis of what they all include. So what is like a typical motivation that we see for manufacturers specifically to be interested in AI agents? As you've probably also learned yourself, it has major potential for improving the efficiency of your operations, be it by reducing equipment downtime with predictive maintenance, or optimizing your production processes. Across operations, agents offer a lot of potential here. Also in terms of breadth and coverage, being able to handle more production decisions, more quality checks and tasks with the same workforce by enhancing these with agents as a powerful tool. Consistency, also a big topic in manufacturing. That's always a high priority. With agents, you can really standardize your approach, be it to equipment monitoring or to process improvements by having the same basis for across different shifts, across production lines, or even factories. And also, definitely not to be omitted is the topic of employee satisfaction. So with agents, it's really an opportunity to automate and streamline some of these monotonous tasks to allow employees to really focus on more high-value problem-solving and continuous improvement work that's actually more engaging and rewarding. So what are some of the use cases that we see in the manufacturing space? I've collected here just a few examples that we've worked on here in Dataiku or that we've discussed with customers, some that we have in production, some that are concepts, and these I'd like to share. By the way, if there's any questions, feel free to write them into the chat, into the Q&A, and we'll get around to answering those either by chat in parallel or afterwards. So we kind of see three core areas where agents are really creating tangible value on the factory floor. And it's important to note here that, in our opinion, it's not really about, it's definitely not about replacing people, but more about fundamentally enhancing how we automate processes, how we empower our workers, and how we connect our operations to direct business outcomes. And that's kind of a theme that carries through all of these. So beginning on the left, we have the topic of process automation. So this is kind of the most, I guess, simplest area of agents. It's kind of the foundational layer for the other ones. So here you're targeting repetitive rule-based tasks that just consume a lot of valuable time and are kind of prone to human error typically. And the main outcome here is a cost reduction by avoiding these mistakes or automating them. So for example, on the topic of, you could have automated quality assurance reporting. So here you could imagine basically a quality manager who would normally spend the first hour and a half of his shift every day pulling data from different systems. So process control data from the line, lab results, manual inspection logs, basically just to build a daily report. Where here an agent could completely automate this so that when he starts his shift or when she starts her shift, you can basically have a report waiting in the inbox with a highlight of what the trends were for the night shift, any flags of irregularities, and this could really, save a lot of time for someone like this. Similarly, with having an agent, for example, in place for monitoring the safety in a plant, this could really drive down compliant risks and, of course, prevent accidents by automating this monitoring and flagging anomalies or even ensuring that processes are followed. Then moving on to the center pillar, here we have the topic of worker augmentation. So here the typical result is a massive jump in productivity. So again, this isn't about replacing like a skilled workforce, it's really about enhancing it. And the key benefit here is then this improved effectiveness. So for example, the second one we'll be demoing today, maintenance scheduling assistant. Here the idea is that you have a significant lever to improve your OEE. So basically, instead of scheduling maintenance in a manual way with an agent, you can really do it in an optimal way, get recommendations very quickly in terms of what to prioritize, and really go from a very complex multivariable problem that takes a long time to do ideally to a very quick solution in a matter of seconds sometimes. Similarly for operating machinery, as we have here in the first example. So especially for complex machinery, for example, if an operator is relatively new, an agent can provide suggestions for how to change settings depending on certain conditions that are currently happening or certain products that are being produced, and give warnings if any certain operations were missed or certain steps were omitted. Then on the right, finally, we have what we call intelligent business chains. This is kind of like the most advanced area, in my opinion, and but also at the same time the most strategic application of agents, where you're really starting to get the most value. And here it's really about connecting basically historical and real-time intelligence from the factory floor directly to commercial and financial outcomes, and then thereby really enabling new revenue models even. So it could be around the topic of optimal processes and operations. So with the production process optimizer, as we've written the concept here, the idea is basically to have an agent monitoring the entire plant. So let's say, for example, you have critical raw material shipment that's delayed. Here, a human planner could take hours to recalculate the schedule. But with an optimizer agent like this, it could assess the different impacts and evaluate basically which orders have the highest margin, which sequences the entire production flow could be implemented to maximize the profitability despite the disruption, and basically give a suggestion for how, if you're assuming, of course, your manufacturing process is flexible enough, how it could be changed and reconfigured to minimize the effect of such a supply chain disruption. And that could be a major competitive advantage, especially in these days where supply chains are so uncertain and unstable. And then here as the last example, we call this machine as a service uptime agent. And for example, we're seeing even more and more companies, especially industrial equipment manufacturers. So instead of just selling a machine, they sell a guaranteed outcome as a service, for example, 99% uptime. And basically the idea would be that for business models like this, an agent could live on a customer's equipment, one that they're leasing or they bought, and essentially not just predictive failure, but also orchestrate the entire service response, and thereby helping ensure that the SLAs are met. And this really helps companies move basically from a one-time capital sale into an entirely new revenue stream. So a super exciting idea in my opinion. So basically, as you can see, these three pillars aren't really independent. They kind of build on each other in terms of the complexity and in terms of the basis that they provide, basically moving from automating processes up until really creating entirely new data-driven business models. And yeah, these are some really exciting ideas we see. But today we'd like to go into more detail on the maintenance scheduling as we've announced. So at a high level, what is our maintenance scheduling assistant? After I'm done speaking, my colleague Nicola will be giving a live demo, so we'll be able to dive into the details. But essentially, what it does is provides an intelligent schedule and orchestration around your maintenance activities. So it basically analyzes your equipment health, the production demands, the resource availability, to then suggest maintenance operations and which machines to prioritize the maintenance on, as well as a possible maintenance schedule that you could actually use for whatever time frame you've requested. And all this is done through a chat interface here in the second point. So basically, maintenance managers can chat with this agent through natural language and really get immediate responses in terms of what questions they may have. And also, of course, the entire time, the underlying models for this project can be retrained, and thereby continuously improving actually the accuracy of the outputs. So what was our motivation for creating this agent? Essentially, it's the classical challenges you see with traditional maintenance. I'm sure most of you are familiar with these. So having equipment downtime, that's of course a super critical topic. This typically costs in manufacturing intensive industries tens of thousands per hour easily. And if you're not able to predict these unplanned events and you can't prevent them, and thereby they tend to occur. Then the topic of this whole challenge with coordinating all these different resources that are involved. So you, of course, have technicians that are included. You have to know what spare parts are needed. You have to find the right production window. You need to know what bottlenecks and equipment dependencies there are. So very complex process to solve manually. There's, of course, the topic of knowledge dependency risk. So you often, especially for older equipment, have only very experienced and few technicians who may know how to do the proper maintenance there. And when these aren't available, that's an immediate bottleneck. And then also this topic of having multiple priorities. So maintenance is a topic that involves a lot of different departments. So for example, the production teams, of course, want to maximize the uptime of the production. All the maintenance teams want to have the maximum service window to be able to do the maintenance successfully. Finance, of course, as always, wants to keep control, keep the cost low. and it's difficult to have a systematic way to really address all these needs. This is also one area, for example, where classical predictive maintenance doesn't take this into consideration, where we found that with an AI agent approach, it's much better suited to take these different perspectives into account, as you'll see in a moment. So with the actual implemented solution, we expect quite a few benefits. So of course, reducing the time you actually need to plan the maintenance, since this is done automatically by the agent. And this, of course, if actually implemented, prevents unplanned downtime, which has immediate benefits. But also, as in the third point here, you're able to cut a lot of the underlying costs, so that kind of follow through with having unplanned maintenance. So you're better able to allocate your resources, probably reduce your spare parts inventory, reduce your holding costs there, and reduce the number of emergency repairs you're doing, which are always costly. So a lot of these costs can be reduced. Then also maximizing your resources that you're utilizing, and also ensuring more consistency with how you're reaching these decisions. So the agents are always using a certain databases, as we'll show shortly. And this really helps to make the decision process transparent and also repeatable. And a big benefit of Dataiku is that it's very easy to very clearly set up your agents so that you know exactly what databases they're using to make their decisions and make their recommendations, and can get the full transparency and also consistency. And if there's any errors that are occurring or unexplainable results, there's many ways to really trace back how the agent arrived at that decision. So as the last slide before we jump into the demo, here's like a high-level view kind of how we've set up the project. So what does this agent use case actually consist of? So typical, starting at the top, typical persona could be like a factory manager doing a maintenance plan for the month, but also a shift manager wanting to kind of prioritize maintenance activities for the next day. But essentially, it all begins through a chat interface that's native to Dataiku, or they can ask a question to the main agent, which we call the scheduling manager agent. And as you can see here, we've essentially taken a multi-agent approach, where we have a system here where this main central agent coordinates the activities of different agents that are allocated to specific domains that are specialized for specific domains. So we see, for example, floor manager agent here that is used to get information about the past performance of the equipment, observations the operators have made, and any settings that the equipment might have. And it basically has this perspective of someone working on the factory floor. Then we have a reliability engineer agent that gets the past reports of the reliability for each machine. Production manager agent that has the schedule in mind and knows what the order is of the processing steps, so it can identify which machines might be bottleneck machines. And then finally, of course, the maintenance manager agent, which at the bottom we see here, in addition to taking data sets as inputs, it also takes, for example, a prediction model, remaining useful life model, as a tool at its disposal. So we can then, for each given machine, give an estimate for the remaining useful life based on the current operating conditions it has, as well as, of course, maintenance documentation in terms of the steps to do. And essentially, all these different agents contribute and give their feedback to the respective domain to the central agent, which can then use this information to give a response in terms of what maintenance scheduling questions to answer, and suggest a maintenance schedule depending on what was prompted. So now that you've seen a high-level overview of kind of how it's all working, I'll hand over to my colleague Nicola to go into the live demo. Over to you, Nicola.
Hello, everybody. So I'm Nicola, and I'm a senior data scientist. I built the technical aspect of this solution along with Anari. I see that we have already a very interesting question from Carl, Hiroshi, and Debra. So I've already answered Carl, but I'll try to illustrate it during the demo. And Hiroshi and Debra, I'll try to answer your question at the end of the demo. If you have any other question during the demo, feel free to send them either in the chat or the Q&A. So let me share my screen. So I'm going to share my entire screen. There you go. So basically, this is a traditional Dataiku DSS project. And with those agents, what we wanted to achieve is to be able to integrate them in your traditional project. So a project in DSS is a flow of data transformations. So you can see basically that everything is a data set. And then you have those really simple recipes that enable you to transformate your data, to prepare them, to clean them, and to do some more advanced things such as machine learning or statistical models. Agents in DSS follow the same pattern. You now have a new object in DSS that are agents and are really easy to set up. In this demo, what I'm going to show you is how to easily build a multi-agent solution that will tackle a complex issue, which is how do you manage your maintenance schedule while using a solution that enables you to do it entirely using no-code building blocks into your solution. So an agent is simply just an object where you can just double-click on it, manage the version of the agent if you want to update it, and just simply tell him two things. The first one is the prompt. So I'm going to use a scheduling assistant. So this one is the scheduling assistant, and I'm telling him very simply that he has to help me schedule my maintenance, and he can, to do so, manage his tools. So the tools are the second very important aspect along with the context, which is what the agent can do in terms of actions. So to answer Carl's question in the chat, what's the difference between that and the traditional analytics solutions? The agent can choose, depending on what's the task and what the question you're asking him, which tool he can use and in which order, depending on the answer of the tool. For instance, he has access to the other agents as a tool. So if I go back to the flow, I can see that there are links between the scheduling manager and a floor manager that manage operators observation. So each time someone on the floor notices something, he can write it into an Excel spreadsheet that will be used as an input in my project. So I get a simple spreadsheet that has been inputted in my project where I have some non-structured data. So it's simply observation from operators, such as, it seems slightly louder, or there are some scories or things that we might want to focus our attention on. Things that traditionally have been very complex to analyze, but now thanks to agents and to language model, we can analyze those kind of non-structured data. So this agent has access to this type of information. We also have all the other aspects that are at stake when we decide to schedule maintenance, such as the managing the production. So the production manager has access to several things. The first one is the data set of the forthcoming orders to know that, for the next month, I have to fulfill this order. So I will need to produce this and this type of product. You also have a maintenance manager that has access to a little bit more things, because obviously maintenance is at the core of this solution. So the maintenance manager has access to several tools. So let's double click on it to see exactly which one it has access to. So he can read the statistical analysis that we have into the project. More on that later. He can search maintenance documents. So this is especially interesting. It's a folder where you can drag and drop a lot of documents, and he has the capacity to search those documents that have been indexed. But I'm going to show it to you just quickly after that. And then he can read traditional data set that you have. So if I go back to the solution, the entire solution that we have without agents is a machine learning model that try and estimate the remaining useful life of your equipment. So if you know maintenance, you know that's a traditional subject in predictive maintenance, estimating when the equipment is going to fail, what is the remaining useful life of equipment. That's what this machine learning part of the flow is doing. And you get the result of the statistical analysis, which is what variable might impact my maintenance performance, such as the manufacturer or such as the location of the equipment, and then what is the estimation in terms of remaining useful life. For instance, for a certain number of equipment, I only have 9 days of remaining useful life estimated before needing a proper maintenance. So the maintenance manager has access to all those things. And then you get the reliability engineer, who is more focused on is a machine particularly critical for a given process, meaning that if this machine is off for a certain period of time, I will be in trouble because I don't have any machine able to replace it to produce a given product. So those are a lot of elements you have to take into account when trying to schedule your maintenance. So why not using a traditional method here? It's because it really depends on the result of all of those processes. If, for instance, I'm interested in running maintenance of a given machine that has a remaining useful life which is pretty low, I would like to check if there are any orders that will come in and that will need this machine or not. So I would need to ask the production manager, and depending on its answer, I will need to check other tools. So when you need to adapt the entire workflow of the process, that's where agents shine, because they are able to adapt and choose to decide which tool to use depending on the result of previous tools. So that's what they all do. And in terms of deliverable of this kind of demo, it integrates well with the traditional way we deliver results in the DSS project, which is dashboard. So you get a generic dashboard where the first tab is simply what you would get in a traditional project. So you can translate all the results of your statistical analysis in terms of KPIs or charts with filters and anything like that to have at the first glance an estimate of all the KPIs of your maintenance. And then you can integrate your agents in several ways. The first one, and the classical one, is simply a chatbot. So you can ask questions, you can have a dialogue with it, and it will adapt depending on your question. So I can show you an example of a discussion I had with him. So you can just ask him, what should I focus my attention on in terms of maintenance? And the agent will just confer with all the other agents. They will discuss in between them. So it can take a while, and then go back to an answer. So here, what happened is, there is a specific equipment that came as a priority for several agents. So he has only 9 days of remaining useful life. So that's the maintenance manager speaking to the scheduling assistant and telling him, okay, this one should be a high priority. But it's also, and that comes from the reliability engineer, it's a critical piece of equipment with no substitute for one specific product. So we have two factors at the same time, coming from two different aspects of the reflection. And here in this architecture, it comes from two different agents. The maintenance manager telling him that the statistical and machine learning model tells us that this piece of equipment will fail with a 80% probability in 9 days. And then you get the reliability engineer that tells you, okay, this machine, if it's off, we have no substitute to produce a particular product. So this the scheduling agent come on top of that, aggregate this information, and is able to prioritize and to summarize it for you to make a decision. So it just tells you that needs your immediate attention. That's the most urgent. If you have one thing to know about it, it's that this machine needs immediate maintenance. And then you can deep more into what you could do later, which is secondary focus. We have a couple of other equipments, etc. And what is really interesting with those kind of agents is that they are able to confer with you can organize a multi-agent architecture pretty easily. So they can all specialize in a specific aspect, criticality of a component, maintenance, remaining useful life, those kind of things. But they can also uncover deeply nested information that a human could just go over, because there is so many information to take into account, right? So that's this example, for instance. The A0087 is showing performance degradation and minor scoring. So if you have a look at the actual flow, you can see that in the spreadsheet where you had the operator's observation, if you have a look at this line, the A0087, you can see that one operator noted minor scoring on this machine. And that came up because obviously the agent is able to scan an entire spreadsheet and is able to uncover deeply nested information that a human would have trouble doing. If the spreadsheet is especially large, that's something you can go over and not see. And then another good aspect that might answer Carl's question as well is that it's able to adapt to it's able to interact with you and to adapt to what's your main focus. So I just asked him, what if I want to focus on OS updates or operating system? So on some equipment you can have an operating system just the way you have on your computer, and you need updates and things like that. And what we have here is the agent just going back to the scheduling agent, going back to the specified agent, and manage to uncover that you have something you should be focusing on, which is you have one OS version which is pretty problematic, which is called the version 2.1 Vanguard operating system. And how did it manage to find that? It's because in the document I have, so in this folder, I have all the context document that could be useful. And I have, the manual you could get about a machine, which is simply a PDF. And what you get with those, let me zoom a bit so you can see maybe a bit more. And maybe I can remove that as well. No, I cannot. So you have to trust me on this. But what you could have on those type of manual is the software version history, where you have, the reason why we decided to create a new version on a given software. And for the version 2.1 Vanguard, what you would get is non-bug significant issue with calibration. So you get some bugs, and along with this particular element in a PDF file somewhere, you get into the machine learning results. You get the fact that the result have shown the statistical analysis have shown that this specific element, the version 2.1 Vanguard, is at risk of needing higher maintenance. So by focusing on that, the agent is able to go into the documents, looking for information about operating system, is going into the statistical result that shows that this version in particular shows some issues. And so it answers you that if you're interested in OS version, then you should definitely focus your attention on this specific version. And then it updates your priority list by telling you, be careful, those machines are running version 2.1 OS. So now that I know that operating system updates are a priority for you, you should focus your attention, as long as the first one, that we have already identified, you should focus your attention as well on those two items because they are running a problematic operating system version. So that's another good aspect of agents, is that with all this information that you can have on the spreadsheet and the data sets and the statistical result, but also, as I just shown you, the folder with PDF, with any types of text document. If you have a specific priority or something you have in mind, you can interact with the agent, and the schedule, the maintenance schedule, will adapt live depending on all this information and with your priorities. So that's the traditional version, the traditional way of interacting with those agents is using a chatbot. And I'm sure by now you are all used to interact with language model through chatbot. But what we wanted to show as well is another possibility in DSS to integrate agents, which is through web applications. So web applications are simply one possibility in DSS. You have two kinds of web applications. So in this project, we have two. The first one is the one I've just shown you, which is a chatbot. So that's what we call a visual web application. So our chatbot is one visual web application, meaning that it's out of the box, it's running. You can just click on new web app, and on visual web app, you will have access to a whole catalog of visual application that don't need any coding to run. So you can create a new chatbot and decide to focus on a specific aspect. For instance, if I wanted to have something dedicated to the reliability engineer, all I would have to do is click on answers, which is the name of our chatbot, and to connect it to our reliability agent. In a couple of clicks, you could have a dedicated visual application, which is a chatbot with a reliability engineer. I could add a specific prompt to give him some specific instruction, and I could share that with my reliability team, right? But another aspect, if you want to go a bit further, and if you happen to have development teams within your organization, I'm sure that's the case for a lot of you today. You have software development teams that work on specific application, and you want to integrate them into DSS. That's a possibility. So you can just have an actual application. So here, that's one I've built myself, which is simply a calendar application. So that's a calendar application where you can just click and write manually that you want to run maintenance on things, like, for instance, maintenance on B97. I'm just writing random things just to show you. So that's a calendar application. So let's imagine I have a software, I have an internal project who has built this kind of application. What I can do now is I can have it in DSS, connect it to my actual data, and more than that, I can connect it to the agent I've just built in order to improve the quality of my application and to put some AI in it. So what we just delete this one. So what we have here is simply one button where I can just interact with my agent. So obviously it's visually different, but it's exactly the same thing as the chatbot we have seen. And I can just tell him specifically, please schedule, for instance, the rest of the week. Based on the priorities that you estimate are the highest priority in terms of maintenance. And what you would get as a result is exactly that. So that's the actual result of the agent. So you would get automatically you will get something scheduled automatically with the actual explanation. So if we find the same result we had before, so the B0272 is critical because there is a remaining useful life of 9 days and no available substitute. And then as I ask him to do the rest of the week, in terms of priority, now we are at the next one, which is also 9 days remaining useful life, etc. So that's the second big way of integrating those agents. That it's really easy to integrate it into your web application. From a code perspective, I can show you just a bit of code really quickly, just to show you it's really simple. We have made a lot of effort to make it as easy as possible. The level of abstraction of those agents is really simple. So if you have already a classical web application, integrating those is just a matter of several lines of code. Let me just show you. So it's in the code component, which is this symbol of your DSS project. Then you have your libraries. And I've put my project here with the code of the backend, which is doing all the heavy lifting here. And then just to show you, it's just simply this function. So chat with my chatbot. And it's basically a dozen of lines of code to just pass what the user is writing to the actual model. So it's not rocket science. It's working pretty easily because DSS is doing much of the heavy lifting in terms of agents. So that's basically it for the demo of the maintenance scheduling agent. Let me just go back to the question I've been asked in the flow. If I remember correctly, I have Hiroshi who asked about an agent identifying trends. So it's not really the subject of this demo. It's a great question. It's a fascinating subject. It's more into the domain of anomaly detection, and we are actively working on it. So we have another solution which is called Manufacturing Event Tracker, who really try to tackle this issue. But you're right on this, Hiroshi. It's a bit complex for an agent to by itself detect thresholds and trends. So what we decide to do here at DSS is to provide traditional anomaly detection, and then the agent part is not really leveraged for those kind of solutions. We are more into the traditional artificial intelligence solutions, such as you label by yourself what is not normal on your trends, and then after that you do a machine learning lab. But yeah, even with the visual capabilities of new agents, detecting automatically trend and anomalies remain a challenge for agents. Let me just go back to the questions. So it's going to be a bit. So the question I had, maybe I'm going to stop sharing. It's a bit easier, and we can take. Maybe you can take. We can start taking questions. What do you think, Henry?
Yeah, sounds good. I'm also furiously answering questions in the chat, but right. Yeah, I would say we just start at the top and go down.
I remember that. We had a great question by Deborah about hallucinations. So that's remained a big challenge for agent and for language model today. We have seen some great improvement. I'm sure you do also on ChatGPT or mainstream language model. Now there are a lot of loops in those highly advanced products to make sure they don't hallucinate. In this solution, at first it could be an issue like scheduling maintenance on a machine that does not exist. So here you have two solutions. The first one is we have a recipe, so a building block that is called evaluate your language model. So what you would do is you would create a data set such as the one we have seen. So you create it manually with input and what you expect. For instance, what's in terms of maintenance, that would be what's the remaining useful life of what's the machine with the lowest remaining useful life. And you know it's machine A9025, for instance, you know for sure the answer. So you write exactly the answer you expect. And this data set is like a golden data set that you evaluate your agent on. So once you've built your multi-agent architecture, you make sure there is no hallucination by testing it on the evaluate your LLM dataset. And as soon as something is off, like answer something that doesn't exist, you get a warning signal. Or if it works properly and there is no hallucination of this entire dataset, you know that you have lowered the probability of having hallucination with this given architecture. Obviously, you cannot eliminate it, but you can lower it by testing the LLM. And another solution is what we call a reflection pattern, meaning that you can, let me show you basically what it looks like. I'm going to share my screen again. So you can have, you can have a lot of architecture that you can build. This one is a project not dedicated to manufacturing, it's more general, but you can see that, for instance, this one, you could have, like, for instance, 3 or 4 agents checking the results of the previous agent to make sure it exists. Because what happens usually is that one agent can hallucinate, but not 3 in a row, right? Because they don't hallucinate in the same manner. So if you ask a first agent to schedule the maintenance, and then if you ask a second agent to check if those machines exist, then you basically eliminate the risk of any hallucination, at the cost, obviously, of having to run the thing twice. So in terms of API cost with your language model provider, it's a bit more expensive, but you basically can eliminate the probability of having hallucinations.
Great. So I sorted the questions by upvotes, which is a nice functionality I'm just seeing. The top voted question is from Hiroshi Ochi, asking, how do the AI agents get the information? Number one, the input from the equipment, so for example, noise readings or machine speeds and stuff. And then number two, know what the threshold is to set a trigger action. And so, maybe I guess the quick answer would be that for our specific case, correct me if I'm wrong, Nicola, it's we're not doing like anomaly detection, which is of course is a classical predictive maintenance use case. In this case, we're mainly focusing on analyzing the historical maintenance data. So we're not just doing simple triggers. There was also 1 or 2 other questions on this. It's not just simply looking at a certain thresholds and then setting off a trigger. Instead, it's looking at the historical performance and then giving a recommendation. When is it likely going to fail based on how often maintenance has been needed in the past? So it's a bit of a different maintenance use case as you're describing, Hiroshi.
Yeah, and in terms of information, you have a lot of possibilities. We have seen dataset can be a possibility, and you can plug an agent on it. We have seen also that you can have context documents. So you have a folder and you drag and drop your document, your PDF files in it, and that can be an input for dataset. And then we have seen also a third way, which is another agent can bring information to this specific agent. And all of those can be scheduled using the scenario aspect of DSS. So we have a section called scenario where you decide what triggers what. So you can say, for instance, as soon as someone add a document into my folder, I want to trigger one agent to actually read this document and answer a specific question and output the result there. So there are a lot of possibilities, but basically that's, the main possibilities are there.
Exactly, and you could even probably implement a streaming approach. Dataiku has a streaming plugin for Kafka.
Exactly,
and we have if you want to do the live anomaly monitoring, that's what you could use for what you're describing. But in this case, we're not doing that. But great question. So another question here, the second most top voted is kind of a challenge of, do you actually need agents like this? So Arnaud Das is arguing that it's basically what we're describing as a complex way of replacing a 15-minute stand-up at the beginning of a shift.
That's exactly
thing.
that.
Yeah.
But the idea is maybe 15 minutes of a stand-up. You can compute basically the cost of 15 minutes. Here I could argue that for this specific maintenance aspect with all the documents, it might be more than 15 minutes. But let's imagine it's 15 minutes. You can compute what 15 minutes in terms of preparation for the people to come to the stand-up, to be ready for those things, so reading the documents beforehand. The total time cumulated times the salary of all those brilliant people that I'm sure are well compensated. In terms of cost, I'm not sure that would be the actual cost we have for this specific solution, which is like a couple of cents each time there is one request on the language model. So the idea is that in terms of cost, it's pretty hard to beat, even if it's 15 minutes plus the preparation. And the idea is, as Henry mentioned, it's not to replace people, or it's not the idea of replacing the stand-up with that. It's more the idea of having the computer there and helping people at the stand-up make the best decision possible. So you still have your stand-up, but this time you have the result of the DSS flow and the suggestion by the agent, and we can discuss it. Maybe that's not the perfect approach. Maybe we can leverage what the agent has told us, but the idea is to make this 15-minute stand-up more valuable than it was before.
Yeah, and I mean, I spent multiple years going from company to company doing lean transformations and joining these stand-ups like this. And having one that efficiently runs in 15 minutes and identifies the ideal maintenance prioritization without any arguing or overseeing some details is actually quite hard to achieve. So I don't think all companies are necessarily possible to have the ability to do that effectively. But yeah, in the end, it's more of a tool to support this. Okay, but it's definitely very important when you're thinking about the topic of agents to remain critical and really ask yourself, okay, is this really a meaningful use case where it actually adds value, or is this something that might not be that have not that tangible value? And then you should, of course, think about maybe doing a different use case, especially if you're kind of in the POC phase at your company and you're trying to still prove the value to your management. It's important to remain critical. So it's definitely a good thing to ask questions like that. Scrolling down, so I've answered some of these questions.
I'm sorry, Henry, I'll let you manage the question.
Yeah, no problem. So I think in terms of we had another question, what's the business model, the value proposition of the tool? I think you kind of summarized this nicely, Nicola, in terms of
the idea is, once
efficiency.
Again, leverage, gain some time. There is an economic value to it because you can replace tasks that exist before will be done quicker. You can increase the performance of doing the same task by having those assistants along with you. And also something that we don't think about is it automates things that can be a bit boring for your colleagues, such as reading the operator's report or consulting the statistical analysis. So the idea is to make their job more interesting by automating the boring task, right, which is what it is about. So that's the whole value proposition, cost, performance, but also improve the quality of life of your colleagues.
Yeah, exactly. Then we had two questions more specifically to Dataiku. One from Shivaram Yamunya, asking what kind of factories or production shops are using Dataiku. So definitely check out our customer stories on the link that Marisha shared. But in general, we're across all industries that you can imagine, basically. Energy, automotive, aviation, semiconductor. We're completely, basically, industry agnostic. And these specific applications that Nicola and myself develop may have more relevance. Some may have more relevance to certain industries, but in general, we kind of try to really target business needs that are found across any industry, such as, for example, maintenance. Then we had a question around the timeline. So someone's asking, what's the estimated project timeline for developing such a system end to end? I mean, the answer is, as always, it depends, but maybe Nicola, you can give a kind of an explanation of what the factors could be to determine that.
Yeah, in terms of pure technical aspect, I can tell you how long it took me. It took me about a month, half time, because I have other project to do at the same time. So for this initiative, yeah, I had maybe a third or half of my time on it, and I've spent a month on it. Obviously, I'm used to the platform, but I'm not particularly quick or anything like that. Any data scientist could do the same, and even people that are not data scientists, because most of the things I used were not coding aspect. Obviously, the web app that you have seen with the calendar, there is a bit of code involved, but for the rest of the solution, there is no code involved. So that would be way faster than a month to actually do it. Most of my work was like, yeah, try to make the calendar, look nice and interact well with the AI, but all the other aspects are pretty quick to use. It's more, it's more about knowing which data you have and connecting to your existing data source. That's the bulk of the work. But knowing your data, you already know it, you already have the expertise, and connecting it to it, that's the plumber work you have to do. That takes a lot of time. Actually, using DSS once the data is there is pretty quick and pretty straightforward, and that's our value proposition. Really, is to be able to build such a solution quickly. Why quickly? Is because you will need to iterate before finding the architecture that works for you and the prompt that works for you. So we try to make this as smooth as possible, and that's pretty simple to build, really. So yeah.
Perfect. And then, of course, the big determinant is like, is your data already, you know where your data is? Do you know what data you need? The nice thing about these pre-configured templates we make, which we call business solutions, is that they're like the flow and the backend is more or less already there, and you just need to adapt it to your own needs. So yeah, in the end, it comes kind of down to how much adaptation you need to do if you're asking about the specific use case. But in general, Dataiku, I mean, across our customers, we definitely typically see an acceleration of more than 50%. Some customers improving their speed for ML projects threefold. So it definitely results in a lot of acceleration.
And one thing to mention is both Henry and I, we work in a division called Business Solutions, and we build those kind of solutions ready to use. So use the DSS, you get an option. So let's imagine I'm in DSS on the home page. I can either create a new project or create a Dataiku solution, and there you have a whole range of domains such as manufacturing, and a whole range of solutions that you can implement quickly to accelerate your project at the beginning. So to make it even faster, to leverage our own expertise, because I'm specialized in manufacturing, and we have also data scientists and subject matter experts such as Henry specialized in manufacturing, but also in a lot of different subjects. So that could accelerate your projects as well. And after that, we also have a service solution that can help you either to build with you or entirely for you solutions as a service.
Exactly. Okay, then we had a bit more. We still have some time, so we have a bit more detailed questions kind of on how the agents are working. So, for example, one question is, once the updates are done, as pointed out by the agent, where is the update log stored? Is the PDF updated or some other location? So in this case, there's not really like if you're talking about the documentation of how the agent reached its decision, that's on a separate area in Dataiku, where you can we call it traces, where you can see kind of what's the steps that the agent took. Otherwise, here you have the chat history of any questions you ask the agent. The chat history is saved, so you can just scroll up and see what the answers were from the agent, as well as what its reasoning was. I hope that answers that question. Then we had a question. Someone noticed that there's a folder located throughout the flows, and they're asking if this is to specify information to be reviewed at the specific step, or if it's a RAG style retrieval at each step.
Yeah, that's a RAG style. Yeah, and you can do it. You can do whatever you want with it. So I can show you more in detail. So that's RAG. Yeah. What we have. So let me just go back to the flow. So that's a folder with all my documents. I can drag and drop or add a file from my computer. So that's my computer. I won't add anything, but you get the idea. With several types of documents, you can also put in Excel spreadsheet at the CSV folder, at the CSV format. It works well. And then you can either have you have a recipe to create what we call a knowledge bank, but that's RAG basically. And then you can have language model recipes, or you can so a language model recipe is simply a one-shot prompt that you want to run. So I have one single shot prompt that I will be able to build anytime I want, or I can schedule, but that's one shot, right? Or I can just create a tool. So I have a section with tools, which are there, agent tools, and search maintenance document. So that's my title. That's how I decided to call it. But basically, it's connecting it to the knowledge bank I just created. So I create the folder. With the embed recipe, I create the knowledge bank. And now after that, I have a tools that is basically do some RAG on those documents. So search this knowledge bank. And then in the agents, the maintenance manager has access to these specific tools. So that's the one, search maintenance document. So you can decide which agent can do some RAG and which agent cannot. And you can have several folders with, you can do it pretty easily. It's simply a matter of clicking to create the recipe and then drag and dropping the documents, creating the tools and giving the tools to a specific agent.
Perfect. Looking at some more recent questions. What's the difference between Dataiku platform and Microsoft Copilot Studio? Yeah, good question. I'll try to keep it short. And it also, of course, depends on exactly which functionalities you're prioritizing. But essentially, basically, Dataiku, as mentioned at the beginning, we see ourselves as the universal AI platform. So if you need like a unified collaborative platform for the full data science workflow from beginning to end, from data prep through to deployment, especially like in an enterprise or team setting, if you want the no-code functionalities, that's really the strength of Dataiku. Copilot is specifically designed for a coding assistant. So essentially, Dataiku has a wider scope, would be the shortest answer to that in terms of the main differences. The application or project built using Dataiku agents is scalable and supports concurrency. So now that question is a great question going towards the actual deployment.
Yes, no, yeah. The entire platform is around this paradigm of creating a job, having the job that runs. I could show it. I'm going to show it. The entire platform is built around this idea of when I'm in the flow. So let's say, for instance, I want to do something such as prepare a recipe. I can click on it and click on build. I'm not going to do it now, but if I click on run on this one, I have a section called jobs. So this one, and those are all the jobs. So they either fail if I'm doing something wrong, or they are validated. And all those jobs are scheduled and are running concurrently on your instance. So it manages concurrency the same way other platforms are doing, such as Databricks or Snowflake or anything like that. You can create jobs and they just run concurrently without any issue. That's the entire platform. And that was built way before the agent came. And so the agent are just, piggybacking this architecture. So those calls are done concurrently. And it's scalable. Yeah, it depends on your instance. But, API calls, because those in the end are API calls to a language model provider, whether it is external or internal, because we can also host our own language model. They are pretty light most of the time. So in terms of scalability, it's entirely fine. And it entirely depends on the size of your instance. If you have if it's a big instance, you will be able to do more jobs. And we support obviously orchestration tools such as Kubernetes. So any project can be either on Kubernetes or just on your instance. And depending on the size of the computer, the virtual machine that you install DSS on, that will scale.
Okay, we have 20 seconds left. Maybe one more question. So commenting on which agents you chose for reasoning models and for why. So I think to keep it short here, so Dataiku is compatible with all the typical LLMs that are available, as Nicholas is showing. essentially, yeah, it's typically a matter of testing a few different ones. It depends on, of course, which ones you have access to at your company. But Dataiku makes it very easy to compare to see how the results are for each one.
Yeah, you have can have a separate team establish connections, so it's hidden a bit from the traditional user. In administration, you have connections, and then you have a lot of connection to. If I click on new connection, we support obviously all the basic connection, but as well as the agent connection. So in terms of LLM, we have almost everything. And then in your agent, as I was showing you, it's just a matter of selecting the connection that has been created by your ops team, for instance, or your IT team. And so after that, it's just a matter of the type of tasks and the expertise of the data scientist. For instance, for certain tasks, you can observe that the Claude from Anthropic is a bit better. For some others, you want something quick and a bit less expensive. So 4o Mini from OpenAI should be better. Things like that. So I made some choice in this project based on expertise and experience. But those things can change really quickly. You can have new models coming up really quickly. So one strength of the platform is it's completely agnostic. You just need to create a new connection, and you can change the LLM model with one click. For instance, this one is O3 Mini. Let's imagine 3.7 just redefined what edge performance is like. I just have to click on this one, and that's it. I click on save, and the project just changed, and I adapted myself to a new LLM landscape without being, closed into a specific vendor.
Great. I'm being told it's okay. So let's wrap up after this question. I think we were able to answer that one nicely. The last one I guess we could answer is, can the entire solution or workflow be exported as code?
The short answer is no. You can do a lot of exporting in terms of computation and things like that, because we are built on Python and on SQL, so you get some option to actually export things on that. But once you get a little bit more advanced, such as we manage, knowledge banks and language model and things like that, you cannot export everything as code just as is. But for each one of the steps, we are pretty transparent about the tools that are used. Any package is used, so you could reproduce it. But if the answer is about exporting in one click and having the entire code, no, the answer is no.
Yeah, and there's ways we offer the ability to basically access the outputs via an API. So some of the analysis results you could possibly pull that way. Regarding the question on MCP servers and our ability to connect, so we can via code we offer the ability to connect, and I think there's an in-progress initiative on offering like a no-code option for connecting to MCP.
Exactly.
But it's currently already possible to answer that question.
Yeah,
okay, so
we have a Python generic recipe that you can put everywhere. So if you can do it in Python code, then you can put a Python recipe in it somewhere. That's what I did. You have seen probably the logo of Python in somewhere in my flow. So you can, if there isn't any no-code solution out of the box, you can still write a couple of lines of code. So if it's possible in Python, it's also possible in DSS.
Great. So then I think we'll wrap up for today. First of all, thank you everyone for the big engagement, all the great questions that were asked. A lot of fun to answer these, and also for the big turnout. And it was a pleasure from our side to share our point of view today with you guys. We'll be sharing a recording of the session where you can also then see the slides. And we'd be, of course, more than happy if you reach out to us individually to have further discussions. At the end of the presentation, you can find my contact info, so you'll be able to reach out to us, reach out specifically to me via that, or otherwise through our general contact options. So thank you again for everyone for joining, and hope to see you soon again.
Thank you.